Section 1.6 gets at the important concept of completing the square. This is a process that we did use in our pre-college math experiences when we were solving equations by completing the square. Now, solving these equations, we had the advantage of working on both sides of the equations, so some problems became easier as a result. For instance, we had something like 3x squared plus 18x plus 12 equals 0. And the first thing we did in these problems was we subtracted c, or that third term, from both sides. And so when we subtracted that 12, that left us with 3x squared plus 18x equals negative 12. The next thing we did was we divided each term by e. Sorry, by a. Where'd the e come from? A is the first term in front, so when we divide everything by 3, the 3 divides out, and we're left with x squared plus 6x equals negative 4. And now we get to what is actually called the completing the square step. The process of completing the square is finding this value that we are going to add to the equation. We're going to add 1/2 of b, the middle term, squared to both sides. So b here is 6, so half of 6 squared. Well, half of 6 is 3, and 3 squared is 9, so we're going to add 9 to both sides. And when we do, we get x squared plus 6x plus 9 equals 5. And then finally, the next step we would take would be to factor and solve. And the nice part is we know it's going to factor to something squared. That's why we added the 1/2 of b to both sides. So we take the square root of the first term. The square root of x squared is x. We always take the sign from the middle, which is plus. And we take the square root of the second term, 9, which is 3, and make that equal to 5. And then we continue by solving from there. The opposite of squared is to take the square root of both sides. Squared and square root are opposites. So we have x plus 3 equals plus or minus 5. Subtract 3 from both sides, and we have our final answer that x is negative 3 plus or minus the square root of 5. The big thing here, though, that is really what's called completing the square is step 3, when we take that 1/2 b squared, 1/2 of b squared, I should say, because we do the half first, and use that to make something that's a perfect square. We're going to go through a very similar process for today's lesson to do what is I'm going to call completing the square on an expression. And the difference between an expression and an equation is with an expression there is no equals, which means we can only work one side of the equation, which means we're going to have to tweak this process a little bit. Same problem again, 3x squared plus 18x plus 12, but this time it's not equal to anything. It's just an expression that stands alone. So there's no solving. We'll never know what x equals. Instead, we're going to make this into a prettier, more useful form. In our future units, we're going to look at graphing equations. And when we graph the equations, some forms are more useful than other forms to help us make a quick and easy graph. Completing the square puts it into a useful form. So right now we're going to look at the complete the square process, and then in a future chapter we'll look at how that useful form can turn into a graph. But for now, the first step we're going to take is going to be to factor a out of the first two terms. This is similar in the solving when we divided both sides by the a. Here we can't divide both sides by a because we only have one side to work on. So instead, we're going to focus on the first two terms, and we're going to factor the a out. We'll factor the 3 out, leaving x squared plus 6x. Plus 12, notice, is outside of the parentheses. The next step we're going to do is our actual complete the square step. We're going to find that 1/2 of b squared. We're going to do two things with it. We're going to add it inside the parentheses. But we can't do the same thing to both sides. So we can't add it to the left and add it to the right. So to stay balanced with something that we've added, we have to subtract it. Leave a space. Subtract it from the end. Now in the space here, I'm going to make a note that we need to also multiply by a. Because when we add it inside the parentheses, you could think about that 3 could potentially distribute through the parentheses, which means it's also going to distribute to the number we add inside. So to stay balanced, to make sure we didn't add any more than we took out, we are going to need to subtract a times that magic number that completes the square. So in this case, again, half of 6 is 9. I'm sorry, half of 6 is 3. And 3 squared is 9. So we're going to add 9 inside the parentheses. And we're going to subtract 9 times the a outside the parentheses. When we do that, we have 3 times x squared plus 6x plus 9 plus whatever 12 minus 9 times 3 is. So step 3 to finish this off is going to be, instead of factor and solve, we're going to factor and simplify. 3 stays out front. The parentheses are always going to be a perfect square because we picked the number 9, which would force it to be a square. So we take the square root of the first term, which is x, the sign from the middle, plus, and the square root of the 9, which is 3. Then we simplify the last part. 9 times 3 is 27, and 12 minus 27 is negative 15. We have now completed the square on the expression. These 3 steps that we have outlined in blue, green, and orangish yellow, whatever you call that, probably more orange, are going to be the 3 steps that you're going to use on every problem on the 1.6 homework. This process is one you need to know very well, especially when the problems become a little bit more involved, like involving fractions. Now we go through the same process, the same 3 steps. We just might need to use fractions along the way. For example, if we have 8x squared minus 24x plus 13. Step 1 was to factor a out of the first two terms. So we factor 8 out, leaves behind x squared minus 3x plus 13. Step 2 is to complete the square, which means we're going to find half of b is 3, squared. Well, that's 3 halves squared, and we remember to square a fraction, we square the numerator and denominator. So that's 9/4. Fractions are okay. We're going to add 9/4 inside the parentheses and subtract 9/4 outside the parentheses times a, which is 8. So now when we factor and simplify, we know it's going to factor to a perfect square. Square root of the first term, the square root of x squared is x, sign from the middle, and then we'll take the square root of the last term, the square root of the 9/4. Just like our exponent property to square top and bottom, with square root, we will take the square root of the top and bottom. Square root of 9 is 3, square root of 4 is 2. And then we have to simplify the 13 minus 9/4 times 8. What's nice here is 8 over 4 is 2, and 9 times 2 is 18. So that's 13 minus 18, which is going to be a -5. And we have now completed the square, putting the expression into what's going to be a more useful form to help us with things such as graphing or analyzing the expression. Let's try another example with some fractions. This one didn't use a lot of fractions. Maybe this one will be more interesting. How about we try 3x squared plus 15x plus 10. Now let's do plus 12. Change the problem a bit, make it a little more interesting. Same 3 steps we're going to go through again. First, we're going to focus on the first 2 terms, and we're going to factor a out of the first 3 terms. So when we factor a 3 out, we're left with x squared plus 5x plus 12. Again, now we will complete the square by finding 1/2 times b, which is 5, squared. That becomes 5 halves squared, or 25 over 4. So we're going to add 25 over 4 and subtract 25 over 4 multiplied by the 3 out front. Now when we factor and simplify, we have 3 times the square root of x squared is x. Take the sign from the middle, plus, and the square root of the fraction, 25/4, top and bottom. The square root of 25 is 5. The square root of 4 is 2, squared. Now we're going to have to do a little bit more work to evaluate this mess over here on the side. First, in order to subtract, we're going to need a common denominator. Right now that 12 is over 1, so we're going to have to multiply by 4 over 4. So that's going to give us 48/4 minus 25 times 3 is 75/4. 48 minus 75 then is going to give us -27/4. And that'll become our final solution. Let's try one more, even more interesting fraction problem. Let's look at 5x squared plus 3x minus 2. It doesn't feel like there's fractions. There are. Grouping the first two terms together, we factor out a. Here a is 5. But 5 doesn't factor out really nicely out of the 3x. That's okay, we just need to have an answer that is a fraction. So when we have 3 and we divide out 5, what's going to be left is 3/5 x minus 2. So we end up with a fraction in the middle. Now when we complete the square, we take 1/2 times b, which is 3/5 squared, or 3/10 squared. 3 squared is 9, 10 squared is 100. We are adding 9 over 100 inside the parentheses and subtracting 9 over 100 times 5 outside the parentheses. Now we have 5 times square root of x squared is x, sign from the middle is plus, and the square root of the fraction, 9 is 3, over 100 is 10, squared. Then we have to deal with this mess again. Fortunately, the 5 over 100 is going to reduce, leaving 20 behind in the denominator. So 20 is our common denominator. So we're going to multiply times 2 times 20. And that's going to give us negative 40 over 20 minus 9 over 20 is negative 49 over 20. And we have our final solution. This process of completing the square on an expression goes through the same 3 steps every time. You should have these 3 steps memorized. First, we factor out the a, even if it makes a fraction. Second, we complete the square by finding 1/2 of b and squaring it. Add it inside the parentheses, subtract it times the a at the end, and then factor and simplify. Where this process is going to be useful is when we're working with some complex expression that has a quadratic portion. For example, we might have 1 over 2x squared minus 16x plus 5. And you notice it's got a portion down here that's a quadratic. When we get to graphing in our future chapters, this is going to be very difficult to graph the way it looks. But if we were to complete the square on that quadratic portion, it becomes very easy to graph. So let's look at how we can complete the square on that quadratic portion. So just looking at the 2x squared minus 16x plus 5, the quadratic portion, we first factor a out of the first 2 terms. Factoring out of 2 leaves x squared minus 8x plus 5. We then complete the square by taking the middle term, negative 8, and dividing by 2 and squaring it. Half of negative 8 is negative 4. Squared is 16. So we're going to add 16 inside the square root and subtract 16 times the front number, 2, from the end. When we factor, this is going to give us 2 times stuff squared. The square root of x squared is x. Sign from the middle. Square root of 16 is 4. And then when we do the 16 times 2, that's 32. 5 minus 32 is negative 27. And so now the expression becomes 1 over, going back to the original expression, now it's 2 times x minus 4 squared minus 27. We have completed the square on the quadratic portion of the problem. Let's try another one. How about we do the fifth root of negative 4x squared plus 5x minus 2. Again, we'll notice that this has a quadratic portion in it. So we're going to focus on the quadratic portion, the negative 4x squared plus 5x minus 2. Going through the exact same steps, group the first two terms together and factor out the a, in this case the negative 4. When we factor out a negative 4, it now becomes positive x squared and negative 5/4 x minus 2. Be careful with the negative in your signs here. Now we're ready to complete the square by finding 1/2 of b squared. 1/2 of negative 5/4 squared is negative 5/8 squared, which is a positive 25 over 64. So we're going to add 25 over 64. And from the end, subtract 25 over 64 times the front term, which notice is a negative 4. Now when we factor and simplify, we have negative 4 times stuff squared. The square root of x squared is x, sign from the middle, and the square root of 25 over 64 is 5/8. And then we have this mess to deal with. One thing I notice is a negative times a negative is a positive, so now we're actually adding at the end. And 4 over 64 reduces to a 16 in the denominator. 2 is currently over 1, so the common denominator is 16. We will multiply by 16, top and bottom. And that gives us negative 32 over 16. And now it's plus 25 over 16. Negative 32 plus 25 is 7. And it's going to be negative, so negative 7/16. And we have now completed the square on the quadratic portion. Sticking that back into the original expression, which was a fifth root of negative 4 times x minus 5/8 squared minus 7 over 16, we have completed the square on the quadratic portion of the problem. So by way of review, we've got 3 steps that we're working through to complete the square on an expression. Every problem exactly the same. We'll factor a out of the first 2 terms. Then we complete the square by finding 1/2 of b and squaring it, adding inside the parentheses, subtracting times a from the end to stay balanced, and finally we factor and simplify. Section 1.6 is short, only a few problems in it. Take a look at them, complete the square, and we will see you in class.